All right, you guys, and now for number 8, we walk into what we call a arithmetic sequences problem. Well, later on we have geometric sequences, but immediately the massive buzzword that we should be thinking about is the word sequences. Okay, so let me first talk about what sequences are, and then we'll jump into this specific problem. And so a sequence has two different sort of worlds, right? So you have the arithmetic ones, as you saw earlier, and you also have the geometric ones, okay? And so arithmetic ones are for adding and subtracting, and the geometric ones are for multiplying and dividing. And so an arithmetic sequence, an example could be 2, 4, 6, 8, 10. Okay? And so here, each time, what are you doing? You're adding by 2 each time. And so for an arithmetic sequence, the main idea here for the plus 2 is that you have what we call a common difference of how much? A common difference of 2. So that means d equals 2. It's specifically d, and in the formulas that you're going to see for arithmetic, you have the d letter associated to it because of difference. Okay? For geometric, an example I can give you is, for example, 2, 4, 8, 16, 32. And so what's happening here? Well, before it was for adding or subtracting, now it's for multiplying or dividing. So here you have to be multiplying by 2. So 2 times 2 gives 4. 4 times 2 gives 8. 8 times 2 gives 16. And 16 times 2 gives 32. And so here it's not common difference anymore, but rather common ratio. And here is also a common ratio of 2 because it's multiplying by 2. So r has to equal 2. Okay? Why do I talk about R? R because of ratio, and it's relevant to know this small sort of technicality because in your formula booklet, if you go to the part of sequences, okay, it's important to be familiar with the formula booklet, you're going to find that you have 4 formulas, you guys, okay? So you have this first one, this second one, this third one, this fourth one. Now, first things first, you can immediately notice that the two that are up top, which I'm going to put in green, okay, the two that are up top are for arithmetic. And the two that are on the bottom, which are going to be in blue, are for geometric. And so it's important to first know that these tools and formulas exist. So the moment you read the word sequences, you think, okay, these tools are at my disposal. And you also need to know how these tools work, what is related to them, etc. And so as I mentioned earlier, you have common difference for D, which is why for arithmetic, you have D going around, right? While on the other hand, for geometric, which is common ratio, you have an R going around, okay? And so understanding R&D in that sense is already like useful, right? What is the other observation we can do? Well, they both, like the two up top, right, for arithmetic, you have one for nth term and you have one for sum of n terms. And on the bottom for geometric, you also have for nth term and you also have for sum of n terms. Now, sum of n terms makes a little bit more sense. For example, s of 3 means you're adding the first term, the second term, and the third term. While on the other hand, for nth term, that means that, for example, you're trying to find u6, right? And so for finding u6, you plug in n equals 6 into this formula here. See? And so nth term is like you're finding one specific term, and sum of n terms is a little bit more straightforward. S of 3 means you're adding up the first 3. S of 7 means you're adding up the first 7. And now the last thing I'm going to mention is that you have I've been saying this whole time they have 4 different formulas, but I'm sure some of you already noticed, wait a second, don't I have more than one? And I would say, yeah, you're kind of right. Okay? What do I mean by this? Down here for geometric, okay, for the sum, right, you have 2 equal signs. Okay? And so that means that this equation on the left is the same as the equation on the right. Now, do they ask for the same things or not? For example, the one on the left asks for U1, asks for R, and asks for N. While the one on the right asks for U1, asks for R, and asks for N. And so, okay, so both of these equations are technically the same. They might be laid out differently. For example, the bottom has R minus 1, while on the other one you have 1 minus R. But technically, they're asking for the same stuff. There aren't different variables here that they're asking for, and so intrinsically, they're the same, okay? While up here, for the sum of arithmetic, if you take a closer look, you have two different formulas here, right? But what do they each ask for? And so the one on the left is asking for U1, is asking for N, and is asking for D. While the one on the right is asking for also U1, also N, but not D, instead UN. And so these small differences are the kind of thing that the day of the test can really add on to help you know what to do. So guys, these are your tools, and having clear what they ask for, what you need for each, is absolutely essential, okay? And I'm not saying you have to know this by heart, but you first need to have the intuition, okay, the moment you read sequences, you're thinking of, I have 4 tools, right? And of these tools, I remember there was this guy online saying something about like, some of these formulas have some things in common, other things not. You're not going to know it by heart because, spoilers, almost nobody does. But what you will know by heart is, there's a difference. What was the difference? And so you're going to do the same exercise as you did now and say, okay, so there's 2 equations here. For the one on the left, you need N, U1, and D. So you're going to write that down. And for the one on the right, you need N, U1, and only UN. And so that's the main difference here. That is a big hint for which one can be more useful than the other one. And so this is more of a generic approach I'm trying to give you. You guys, in general, the procedure you should be doing is that you read buzzwords. You read, for example, arithmetic sequence, or you read, for example, sum of first, and boom, you're already thinking, okay, so the tools I'll be using are these over here. Now, this exercise is a little bit different because they actually give you And so, as I was saying, for the procedure of this exercise, right, you're going to be identifying the buzzwords. And so, this exercise is a little bit more of a special scenario because, you need to find this. They tell you that the sum of the first n terms of the sequence is given by this here. And so, the formula for sum that you can use isn't just these ones, okay? But it's also this additional one over here, right? And so, the one over here is a special one just for this specific arithmetic sequence, okay? So just for this specific arithmetic sequence, you can also use this sum of this formula, sorry, right? And so if you do the exercise over here that for the formula booklet, you need U1, you need N, you need D, or you need U1, you need N, and you need UN. Over here, what do you need? Look at that. You only need N. And so for part A, part I, for finding the sum of the first 5 terms, well, first 5 terms is a big hint for N equals 5. And so for the sum of the first 5 terms, you only have N equals 5. You do not have U1. You do not have D, right? And you do not have UN, right? And so you only have N, and thankfully the formula they give you only asks for N. And so for part AI, it's pretty straightforward. You just need to plug in N equals 5 into the formula they gave you. Now you plug in N equals 5 everywhere just to be organized. So that means that even this little n is going to turn into 5. So S of 5 equals 5 squared plus 4 times 5 is going to equal S of 5. It's going to be, well, 5 squared is 5 times 5, so 25 plus 20. S of 5 equals 45. So for part AI, we have that the sum of the first 5 terms is going to equal 45. Now let me put this in red, okay? Just so that, actually that looks very ugly. So let's put that in blue to remember that this was my final answer for part AI. For part A double A, we have that given that S of 6 equals 60, find U6. Now before I tackle this exercise, there's a massive sort of thing I want to teach you, okay? First things first, an exercise which has two parts in terms of like part I and part double I, um, they're always going to be related. And so part double I needs something from part I, okay? And more often than not in the IB, although not always, but more often than not, what you do in part B needs something from part A, okay? And so on and so forth. It's not always the case, but sometimes it is, and it can be a massive hint on how to move forward. There's a very direct way to know if it's the case, right? And it has to do with the special word given. And so usually when they say given, it can either be like given what you did earlier, right? But other times the given is just like given and something they give you, quite literally. And so here it's given that S of 6 equals 60, find U6. And so this is a big, big hint. It's like, from part A, part I, plus the fact that S of 6 equals 60, find U6. And so these are a bunch of hints that you identify because first, it's part I and part double I, and secondly, they gave you this with the big, big buzzword, given. Okay, and so this is just test taking skills, and you gotta have that in mind, right? And actually, this shows up all over the place. For example, here you have hence or otherwise, so it's telling you that for part B you need to use that. And over here you have given this, and so given this, you're gonna find V5 for part E. Now, that's just be on the lookout for the word hence. Okay, the IB loves to use the word hence, and just keep it in mind. Okay. Anyways, enough blah blah. I'm pretty good at that. For part A double I, they tell you that S of 6 equals 60. You know that S of 5 is 45 from before. So what is U6? And this is actually very, very straightforward. And let me explain it with the following idea. And so you know that S of 6, actually, let's start with, you know that S of 5 equals 45. And you know that S of 6 equals 60, right? Now, what is S of 5? S of 5 is the sum of the first how many terms? Of the first 5 terms. So S of 5 is just the first term plus the second plus the third plus the fourth plus the fifth. While the sixth, while S of 6, sorry, is the first plus the second plus the third plus the fourth plus the fifth plus the sixth. And so from here, if you do, for example, S of 6 minus S of 5, well, visually what you end up doing is this goes away with this, and 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 this, bada bim, bada boom, boom. So S of 6 minus S of 5 gives you U6. All right, and so technically 60 minus 45 is going to equal 15. All right, and so, well, I mean, if I plug everything in, it would be that 60 minus 45 equals U6, right? And so 15 equals U6, okay? That is what I meant to say. But anyways, I think visually it's very appealing. And there it is, okay? So U6, right? So U6 has to equal 15. Let me put it in light blue just so that I remember that this is what we did for part A double I. Now for part B, we need to find U1. And so for U1, there's a couple different approaches that we can use. There's actually like a lot of different methods. And there's one really quick way and one more hardcore mathy way. And so I'm going to start with a hardcore mathy way because it has a lot to do with procedure and formulas and stuff like that. And so when you need to find u1, immediately ask yourself which formulas have u1. And so you go to your formula booklet, and which formulas have u1? Well, both of the sum ones, right? Both of the sum have u1. And u1 is also up here, right? But what's the problem? Even though one up here, what does it ask for? It asks for d. Do we have d yet? No, we don't. And so you cannot use this one, and you also cannot use this one over here, right? Because you don't have d. And so you only have one remaining option, this formula on the right side. So you have u1? I mean, you don't have u1, but you have everything else. So let me show you how that plays out, right? So you have everything else as you're about to see. So that formula from the formula booklet is S of n equals n divided by 2 plus, no, sorry, parentheses, my bad. Happens to all of us. Parentheses, u1 plus un. And so from here, you gotta start considering, like, what variables are here. And so technically, I did say earlier that you have three. You have u1, you have n, and you have un, right? But technically, and this is about getting familiar with your formulas, getting creative as well, which has to do with you using them a lot. So always start with the formula booklet. Technically, the other variable is also Sn. And so if you find a way to plug in, for example, this, and this, then you only need to solve for u1. Okay, so that's the game plan that we're going for now. Is there a way where I can plug in the other three and get u1 alone? And so technically from earlier, you found that, for example, s of 6 is 60. And so s of 6 is using n equals 6. So, that means down here, I have s of 6 equals 60. That also means that n has to equal 6. And do you have u6? You have u6 because you know that u6 is equal to 15. And so suddenly, you can now plug in all the ones that I put in green. Okay, you can suddenly plug in here, here, and here, and end up with only u1, which is what they're asking for part B. And so from here, if you plug everything in, you end up with 60 equals 6 divided by 2 because of n, parentheses u1, plus u6. u6 we said was 15. Okay, I might have gone a little bit too fast there, so let me go piece by piece. If you first plug in n equals 6, you end up with s of 6 equals 6 divided by 2, parentheses u1 plus u sub 6, right? And so what is s of 6? We said that s of 6 was 60 equals 6 divided by 2 is 3, parentheses u1 plus u6, which is 15. And so from here, because it's all being multiplied, the 3 and the parentheses, you can divide by 3 to both sides. You end up with 20 equals u1 plus 15 minus 15 minus 15. Bada bim, bada boom. U1 equals 5. Okay? So this is the hardcore math way to solve it. You just use the formulas. Always consider the option of plugging in for s of n. I know it's kind of weird because usually you don't. Usually you're trying to find s of n, right? And so you, as long as you practice with these formulas and look at different examples, you keep getting into the creative options, and that way the IB won't catch you. See? And so that is one creative way to use this formula. I know earlier I said you need u1 and un to use this formula, right? These three things. But technically, right, if you have s of n as well, you can start, like, you can have 3 out of 4 and find the last one. See, that's what I'm trying to tell you, okay? Which is what we did over here. Anyways, so that is one way to do part B with the hardcore mathy way. So u1, as we said, has to equal 5. Let me box it in and put it in blue so that we remember that this is my final answer. Now, that being said, there is another way to find u1, which is fairly quick, and I would like to show it to you guys, okay? And so technically, if I look at this example for the arithmetic sequence over here, right? So technically, think about it this way. And this is a very logical approach. And so S of 3, for example, is going to be the sum of the first three, right? S of 2, for example, is going to be the sum of the first two. And S of 1, I know it sounds kind of troll, but technically S of 1 is just the sum of the first one. And so what I'm trying to tell you is that S of 1, it's just the sum of the first one. So S of 1 equals U1, and from here, well, you have this sum formula over there that asks only for n, so you can plug in n equals 1 here. You end up with S of 1 equals 1 squared plus 4 times 1, right? And so S of 1 equals 1 plus 4, S of 1 equals 5. And you know that S of 1 equals U1 by logic, right? And so here you can say that, because S of 1 equals 5, then U1 also equals 5. This is another way to do part B, okay? I'm just giving you all the tools you need. Might as well, show you all the options. Why not, right? Anyways, that is for part B, all right? Technically, you can also plug it in over here. So I'm just going to show you that quickly. Even here, if you plug in n equals 1, you end up with S of 1 equals n divided by 2, parentheses U1 plus U1. Oh, that's interesting. Oh, and n is 1, right? And so S of 1 is going to equal 1 half, parentheses 2 U1. This goes away with this. This is literally proof that S of 1 equals U1, okay? So trust me, you usually shouldn't trust guys on the internet, but just for today, trust me, S of 1 equals U1, okay? Yeah, and then for part C, they use the buzzword, hence or otherwise, write an expression for, and this is interesting, UN in terms of n. And so this right here is very important for us to understand, first of all, what it's actually asking for. And so what it's actually asking for here, when it says UN in terms of n, is basically that UN is alone. Okay, so careful with that. UN is alone, and you have a bunch of different n's on the other side. You might have a plus or 3, you might have a plus 3 somewhere, a plus 2, but you only have a bunch of n's on the right side, okay? And so keep that in mind. UN in terms of n means you have UN alone equaling a bunch of different n's doing a bunch of different stuff. And so it's our job to figure out how that plays out. Now, I think from here there's two different approaches, and part C is kind of hard. Okay, so I'm going to immediately say that part C is kind of hard. So there's definitely a challenge coming up, right? So on the one hand, specifically to this exercise, you have that S of n, right? That one of the formulas for sum has only n's inside of it. And so this might be useful for leaving it in just in terms of n. But you might be thinking, yo, what about un? Don't you need un? Un isn't in here. And so that is when you start thinking, okay, where do you have un? Un, you have it. Actually, once again, un, you have it only in two places, right? Un is only in what I'm putting now in pink. So un is over here, and un is also over here, right? So there's un, and here's un. And so these are two different approaches, right? So the one up top, well, for using this one for getting un, just in terms of n, you need to find d. So if you find d, you're good to go. And for this one on the bottom right, well, basically, the problem is they have s of n here, right? And so, here's something interesting. That equation from the formula booklet is that s of n equals n divided by 2, parentheses, u1 plus un, right? And so you pretty much have all of this because you already have u1, right? And un is the expression you're trying to leave it in. But the problem is s of n. That is what's annoying you. But what is s of n? S of n is also this whole thing. So wow, this is kind of whack, but technically you can say S of n equals S of n, and I know that looks troll, but basically you're plugging in this guy in orange here and this guy in pink over here. And so if you go ahead and do that, you end up with n squared plus 4n equals n divided by 2, parentheses u1, we know that u1 is 5, plus un. And so yes, this looks super nasty, but wait a second. Technically, you only have two variables. Technically, you only have n and un. And so, that makes it a little bit more friendly. So if you get un alone, you end up with un in terms of n. So that being said, to solve from here, you want to get un alone. I think it's easiest if you first multiply everything by 2 to get rid of this fraction. So you end up with 2n squared plus 8n equals n, parentheses 5 plus un. You want to keep getting un alone so you can divide by n, like everything, right? And so, well, technically here, just to be more accurate, would be all of this divided by n. And so this goes away with this. You end up with 2n plus 8 equals 5 plus un. So you can do minus 5. Minus 5, you end up with un equals 2n plus 3. That is a way in which you can do part C. Now, part C is pretty hard to spot, and so let me go over the procedure just one more time. So because you need the expression for un in terms of n, you first thought, where the heck do I even have the symbol un? And you have it in two places. You have it in the equation up here and the equation down there. And so which one is more useful? Well, the one up top, you first need to find d, and with what we've done, we still don't have d. And for the one on the bottom right, well, you have s of n. S of n is annoying. But can you replace s of n with something? You can replace it with this, which is only in terms of n. All right? So that was the logical approach that we employed. And technically, if you find d, then using the equation up top is like doable, right? And so I'm going to show you real quick how you can find d. Now, d is the common difference, right? And you can always find d, and this is important, you guys. You can always find d as long as you have two different terms. And so because you have u1 and u6, you can find d. As long as you have two terms, you can find d. All right, so that being said, you know that, I'm just kind of running out of space here, but you know that u1 is 5, and you know that u6 is 15. And so to reach from u1 to u6, how many times do you apply d? Well, I think it's good to make this like super visual, right? And so if I add a lot of visuals to this, you can put the term u2, u3, u4, and u5. And so technically, yes, you don't know what u2, u3, u4, and u5 are, but you do know that to go from u1 to u6, how many times did you apply d? And so the same idea I did up here of doing plus 2, plus 2, plus 2, plus 2, you can think about it down here as from here to here you did plus d once to reach this guy, right? And then plus d again, 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 right? So how many plus d's was it? It was 1, 2, 3, 4, 5. So that's telling me that u1 plus 5d has to equal u6. Pretty logical, right? And so if you plug in the values, you have that 5 for u1 plus 5d has to equal u6, which is 15. So get d alone, right? Minus 5 to both sides. So 5d equals 10. Divide by 5, divide by 5. d equals 2. And so now that you know that d equals 2, you can plug it in over here, right? And so un has to equal u1, which we know is 5, plus n minus 1 times 2. We know that d is 2, right? Now, I know that this 2 looks a little bit troll in the parentheses being at the end, but guys, it's no different than if it was in the front, Okay, so I'm going to leave it in the front just because it's a little bit more friendly. Blah, 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 blah. But from here, if you distribute, right, you end up with un equals 5 plus 2n minus 2. You end up with un equals, oh, look at that, 2n plus 3. Sounds familiar? It better be. It's the same thing that we got over here. Un equals 2n plus 3. Un equals 2n plus 3. So again, two different ways to approach it. You either identify that, oops, I need to find d, or oops, I need to solve the fact that s of n is annoying me, right? So you either plug in something for s of n, or you discover what d is using the different terms. So yes, keep it in mind, you guys. Whenever you have two different terms, you can always find d, and it's the same for the common ratio, okay, which is actually what's coming now. And so later on, they tell us that considering a geometric sequence Vn where V2 equals U1 and V4 equals U6. All right, interesting. We need to find the possible values of the common ratio R. And so what they're telling you here is a little bit weird, okay? And so first things first, here they're associating, right? I mean, we gotta leave something clear. So for geometric and arithmetic, they always think in terms of U, okay? So like UN is on both, U1, like they both arithmetic and geometric, like they use the letter U for the terms. But over here, they plug in or they give you Vn, okay? And so this is just to sort of like tell you that, okay, when we're talking about the geometric sequence, it will be with V. When we're talking about the arithmetic, it will be with U. And so they tell you that V2, so the second term of the geometric, is equal to the first of the arithmetic. And that the fourth of the geometric is equal to the sixth of the arithmetic. And so if I, before even answering part D, I just highlight that information more visually. So you have that, well, you have some first term, right? Then you have your second, your third, and your fourth for the geometric, right? And you know V2 and V4. And so V2 is equal to the first of the arithmetic. And the first of the arithmetic was, it was 5. V3 you have no idea, but V4 they tell you is the sixth term of the arithmetic, and the sixth term of the arithmetic is 15. And so guys, to reach from 5 to 15 in the geometric, how many times did you apply R? So you applied it once here, and you applied it once over here, right? Now, clearly you ended up with a bigger number, so you know it's multiplying, see? Now technically it's always multiplying because if it's less than 1, it gets smaller, but just for us to think about it, we're going to think about it, it's multiplying, not dividing, okay? Whatever, it's growing, it's got to be multiplied by something greater than 1, okay? So, the common ratio, you apply R twice to reach 15. So 5 times 2R has to equal 15. And so careful, here's a slight difference. It's not going to be 5 plus 2R. We're now in the world of geometric. It's 5 times 2R. And so technically you end up with 10R equals 15. And so from here, because you want to get R alone, what you can do is divide by 10 to both sides. So R has to equal 15 divided by 10. Now, I made a massive mistake here, and I'm going to leave it on the video because we all make mistakes, and that's just fine. See? My massive mistake is that, yes, R is being applied twice, but it's being applied twice by multiplying. It's not being applied twice by adding, which is by putting 2R. It's being applied twice by multiplying. So technically here, instead of 5 times 2R, it should have been 5 times R squared. So I'm sorry, you guys, I trolled you a little bit, but hey, we all make mistakes. I'd rather leave it on the video. And it's a common mistake, so I think it's also a good idea that you leave it on the video. See? Anyways, point is, when you're applying the common ratio, think about it as squared, cubed, etc., because it is multiplying, right? So whenever you have, I don't know, x times x times x, you're going to add the exponents, right? So you end up with x cubed. Whenever you have x plus x, you end up with 3x. You're adding the constants that are in front, okay? So it's a slight difference, and I messed it up. Happens to anyone. Let's proceed, okay? So now I'm putting it as I should have. 5 times r squared equals 15. And so from here, you want to get r alone, so you can divide by 5. Divide by 5, r squared equals 3. Whoops, sorry about that. And so from here, you can, you want to get r alone, so you do square roots to both sides. In order to get rid of the squared, you end up with r equals 3. Now, careful. Because you're square rooting, your answer is going to be r equals plus or minus 3, which actually makes a lot of sense because for part D, they're asking for the possible values of the common ratio r. Also, the possible values is either r being positive or r being negative. If you've never understood well why square root of something gives you plus or negative, let me explain. And so technically, if you're looking for the answer of, I don't know, square root of 4, right? Immediately you're going to tell me, it's 2. Now let's understand for a second why it's 2. It's 2 because 2 times 2 gives you what's inside the parentheses, gives you 4. And so technically, when you write this, you're asking, like in math terms, what number times itself gives me 4. And so 2 times itself gives you 4. So 2 times 2 gives 4. But you guys, negative 2 times negative 2, how much is it? It's also 4. And so that's why for this square roots, if it's base 2, right? I mean, I think it's called base, but whatever. Whenever it's like a normal square root, right? You can do this association, right? So you can do this association where it's either positive 2 or negative 2 because of these two different scenarios, okay? So anyways, for part D, that is why r has to equal plus or minus 3. And so now for E, they tell you that given that v of 99 is negative, find v5. All right, and so this is a little bit of a curveball, you guys. Okay, and so here is something we need to understand. So for all these different sort of values, okay, for your geometric, r can be positive or negative. Now, you haven't discovered yet if r is negative or positive, right? And so this information here is a big hint to see if r is going to be positive or negative, right? And so think about it this way. If you were always multiplying by like a by positive 3, would you ever end up with a negative value in your geometric sequence? Technically no, right? And so if you're multiplying by a positive value and your terms are already positive, they're never going to go negative, okay? But if you're multiplying by a negative value, some of them will be positive and some of them will be negative. Why do I mean some of them? Because, for example, over here, I don't know, let me make something up, see? So let's say you have a geometric sequence of r equals negative 2, right? And so if you're multiplying by negative 2, you can have, I don't know, you can start with positive 2, then it goes to negative 4, then you have positive 8, then you have negative 16. And so, yes, it's increasing, but some of these values are positive, some of these are negative. Now, if you start with a positive, like first term, and r is positive, then your values will always stay positive, right? The only scenario that can be like a little bit tricky, right, is if your first term starts negative. So if your first term starts negative, but your r is positive, then everything will stay negative, okay? And so think about it this way. The only scenario that should really, really catch your attention is if you have alternating symbols. So if you have alternating symbols, that means your r has to be negative. Okay, that is the only hint I can sort of like give you. Okay, so if they're alternating, your r has to be negative. And so here, they're telling you that your 99th term, which is way out, right? So your 99th term is negative. Your 99th term is less than 0. And so if somewhere along my line of math I have some that are positive and some that are negative, R by logic has to be negative. The other way you can think about it is that, for example, in this example, right, the ones that were odd, so V1, this is V2, this is V3, this is V4. So in this example, the ones that were odd are positive, while the ones that are even are negative. And over here, what you can actually end up with is that the even ones are positive, and here the odd one for 99th term, 99 is odd, so the odd ones are going to be negative, right? V5 is negative, that means R has to be negative. So I said the same thing in a lot of different ways. I'm sure one of them worked out for you. See? So anyways, for finding V5, all you really have to do is take this 15 from before, the V4. So you take this 15, you multiply by R, and that gives you V5. So just to be a little bit more organized, actually, V4, right? So V4 times R will give you V5. Okay? So V4 times R gives you V5. V4 is 15. R we just identified has to be negative 3. And so that will be my V5, right? And so 15, right? 15 times negative 3 has to equal V5. And so from here, actually I missed something small over here. So this is plus or minus square root of 3, you guys. Okay? And so technically from here, my bad on that, right? So you do square root of both sides, you end up plus minus square root of 3. Apologies. This is from way earlier, right? You end up with 15 times negative 3 equals V5. And so V5 has to equal basically negative 15 square root of 3. All right? And so apologies for that. On this step over here, everything was going just fine, but I needed to leave it as plus or minus square root of 3. So small detail there. I'm sorry, you guys. But now I recognized it, so there it is. For part E, V5 has to equal negative 15 square roots of 3. That is how you solve number 8, and I hope it helped.